Good afternoon and welcome back to Dr. Logic Awkwardly Does Yet More Modal Logic. In fact, today I'm going to give you a very interesting result, and that is the interdefinability of necessity and possibility given the truth conditions that we've assigned to them. So this is a super useful result that we will be using quite a bit in what comes, because sometimes you just don't want to be talking about necessity. You want to talk about what's possible and not possible instead. Also, sometimes you've got negations, and negations can be a real bugger, and you want to kind of get rid of them as much as you possibly can. This result will allow you to do that. So let me bring up our whiteboard so we can get a clear picture of what it is that we're going to prove. So it is the following lemma, and I'm actually only going to prove half of it. I will leave the other half to you as an exercise for the reader, or in your case, viewer. So if you want to try giving me the other half of the proof, you can stick it in the comments and I'm happy to take a look at it. But the result that we're doing is that for every model M and world W in that model, the following holds. So necessarily phi is going to be true at W in M if and only if not possibly not phi is true at W in the same model. Because this is a biconditional, there's two directions that we need to prove, and we're just going to prove the left to right one. So we will assume that we have a world where necessarily phi is true, and then we will show that not possibly not phi also has to be true. Now, this is also a result that holds for every model and every world in that model. The way that we can make this general claim is by starting from an arbitrary model and an arbitrary world. So we won't make any assumptions about the nature of the frame, about the nature of the valuation. Beyond that, we have found a world where necessarily phi is true. So that is our starting point. Suppose that MW is a model of necessarily phi. What does this mean? This is a statement about truth. So we look at the definition of truth, and it follows that, for every W prime, such that W can see W prime, in this model at W prime, phi is true. So I've just written down the definition of truth for a necessity claim. Now, we want to show that at this same world, not possibly not phi is also true. The easiest way to do that is to assume that it's not true and derive a contradiction from that. So now, suppose that in fact, it is not true that we have not possibly not phi. Now, our truth conditions are also falsity conditions. So we can easily go from the falsity, which is being expressed here, to the truth of some formula. So we know from the definition of the truth conditions for negation that if something fails to be true, then its negation will be true. So that, just writing down that part of the definition, means that we have not, diamond, not phi. Now, propositional reasoning works exactly the same way as it used to. So we can just say by double negation, what we've actually got here is that possibly not phi is true at W. Again, by the definition of truth, it follows that, what's the definition of truth of a possibility? That there is a world, we'll call it W2 prime, such that W can see W2 prime, and on this model, at that world, the thing that is being said to be possible, i.e. in this case, not phi, is true. Now, we can go back to our assumption here that every world that W can see is a world that makes phi true. So let's just go back and label this 1 so that we can refer to it easily. So by 1, we know that since W can see W2 prime makes phi true. And this is a contradiction with the thing that I just went back and labeled 2 so that I could refer to it easily. There you go. So if necessarily phi is true at W, then not possibly not phi is true at W. Exercise for you is to do the other direction. A further exercise is to then take the result of this lemma and show that this corollary is true, that there is validity of the biconditional between, actually, I'm not going to even state it that way. Let's make this even more precise. Here we go. For any atom that you want, necessarily P is going to be true if and only if not possibly not P. And this is something valid. So there's no world in no model in no frame makes it false. Another interesting corollary that you might want to try your hand at is this one, that for every M and every world W in that model, if there is no W prime such that W can see W prime, then for every well-formed formula phi, W makes necessarily phi true. So this harkens back to something we talked about a couple of videos ago, which is that everything is necessary if you're in a dead end. Using the definitions of truth, using some of the previous results that we've either proved or stated here, so this lemma and this corollary, see if you can work out for yourself why this has to be the case. Because we're going to start doing this more often. I'm going to start giving you homework assignments, because the only way to really be sure that you have kind of intuited and absorbed all of the definitions is by working out the consequences of the definitions via proofs like this. So give it a go. It's a good way to check and see if you're learning everything properly. And if you've got any questions, leave them in the comments and I'm happy to chat. Take care and see you later. Cheers.